Motion of center of mass. The equation of motion of the center of mass is given by vector v is equal to vector dr by dt. Multiplying both sides by m and differentiating with respect to time t, we get m into vector dv by dt is equal to m into d square vector r by dt square. This equation can be written as m into dv vector by dt is equal to vector f. In terms of the center of mass of the system, we need to consider only the external forces acting on the system. Relation between the momentum of the system and the momentum of center of mass of the system. mv vector is equal to m1 v1 vector plus m2 v2 vector and so on. This equation can be expressed as mv vector is equal to summation from I is equal to 1 to n of product of mi and vi vector. Conclusion. The total momentum of the system is the same as the momentum of the center of mass. Relation between the force acting on the center of mass and the forces acting on the individual particle of the system. ma vector is equal to m1a1 vector plus m2a2 vector and so on. After applying Newton's second law of motion in the above equation, we get f vector is equal to vector f1 plus vector f2 and so on. Equation A. Conclusion. The force acting on the center of mass is equal to the vector sum of the forces acting on the individual particles of the system. From Newton's third law, internal forces occur in equal and opposite pairs, and in the sum of forces of equation A will be 0. Only the external forces applicable to the equation. Therefore, equation A can be expressed as F is equal to F external, where F external represents the sum of all external forces acting on the particles of the system.
For more such videos on all subjects, practice questions and a lot more, download iPrep and learn unlimited.